particular thing right here corresponds to the improper integral, and it diverges, then my sum's bigger than infinity. Therefore, I think the conclusion, the second part of the integral test, is just obvious, that if this particular improper integral diverges, my particular series has to converge, has to diverge as well. That's all the integral test really says. And you're getting a bit of practice. I say getting a bit of practice. Ah, jeepers. You guys aren't so slow. We are slow. Let's see if you and I can't use the integral test to determine whether or not the very first example, number 6, actually converges or diverges. To determine if it converges or diverges, let's check with my integral test. Example number 6. If I take a peek at the interval of 2 over, you guys help me with this, I'm not reading it correctly. E to the n. What's next?
That's it.
What is it?
Dx.
See, I think I'm wrong. I think I've got to look at the corresponding continuous function. I have to have a continuous function in the integrand's position. Do you guys see my point? And I've got my dx, and x is ranged from 1 on up. Well, for me to determine whether or not this improper integral converges, piece of cake, we've already done this before, haven't we? Actually, how do I do it?
You got to take the limit as another variable approaches infinity of that integral from 1
How are we
to
gonna do
the other
this?
variable.
I forgot.
I would make
sorry.
a.
Can I rephrase that? How do you integration experts at this point?
You make a use of, or can't do
Wouldn't it
trig.
be nice if I had something squared in there? Give me some difference between squares. You know I can, but now when I differentiate, I got radicals all over the place with the chamber.
Wouldn't you want to make a u sub to
U
get
sub
rid
for
of
what?
the e to the x?
So if I let u equal the x, e to the x, what's the derivative?
Well, you wouldn't do it that way. You'd take the logarithm of u, right, to equal
Oh.
x.
Okay, I'm all ears.
I don't know if that's right, but yeah, that's the first step I would do. And then you differentiate, so it'd be 1 over u du
It just sounds so
equals
complicated.
dx. Well,
It sounds so
what's an
complicated.
easier way?
You guys, you're making me cry.
Funky form is 0.
Funky form of 1.
1.
Yes. Ah, isn't that beautiful? Because that's merely going to give me the limit as t plays this game of the integral of, I just think that 2 over jeepers of u times 1 plus u. Do you guys agree? Oh shoot, I messed up my bounds, didn't I? My bounds are going to be, remember, you have a test next Tuesday, right? The bounds are going to be, man, you are killing me. Yeah, you're right. Question mark, question mark. I was thinking maybe just e to the t.
So you said u equal to e to the x?
Yeah, because now I got his derivative upstairs.
How did you get rid of? Oh, okay, never mind.
You sure it's okay?
Yes, yeah. I just saw that.
All right, I don't feel confidence losing from you. But, jeepers, I got to do this. I think now I've got nothing more than limit as t plays this game of the integral from here to here of something over u plus something over u plus 1 with respect to u. But jeepers, you guys, that's just going to give me, is that a 2 and a negative 2? With partial fraction decomposition?
Wait, wouldn't you have got the same thing if you did it the other way?
What do you mean?
with setting or taking the logarithm of u and then
I'll be honest
differentiating
with
that?
you, I didn't go that far in my head.
You would have had the same exact answer.
Really?
Yeah.
Let's try it. You said let u be equal to this. And then
Yeah.
you said
ln of u
ln
equals
u
x,
is this.
and then 1 over u du equals e to the x.
And that means I get to rewrite this, the integral of 2 over 1 plus e to the x is this.
Well, it would be natural
Well-
log of u equals x.
Yeah, see, it would be 1 over u, so you would have 2 over u times 1 plus u
Oh, wait a
du,
minute.
right?
I just replaced the 1 plus e to the x downstairs. Now I gotta replace the dx, and that's just 1 over u du.
Yeah.
See, I'm worried about that though.
Well, you
Well,
take
no,
the natural
no,
log
because
of-
you didn't do it right. E to the x isn't going to be there. It's just going to be equal to x because
Oh, I see your point. My
Yeah.
apologies. My apologies. I didn't take the log successfully both sides.
Yeah.
You're saying that.
Yeah. See?
Oh, all right. Now I agree. I agree. That would work just the same. So everybody, what happens next? So give me this. Ah, shoot. Does that give me 2 times the natural log of, am I walking too fast?
I'll take your word for it.
From here to here. You shouldn't trust me. But that's really going to be this. You guys, I know I made up these examples, but I didn't make them up recently. I have no idea what the answers are. Does that give me 2 times the natural log of e to the t over e to the t plus 1 minus 2 times the natural log of e over e plus 1? Can I start skipping steps? No. Please. I mean, I think if I allow t to increase up now, yeah, this whole input's going to positive 1, which means the entire natural log business is just going to 0. Tell me if I'm talking too fast. But I think that means in the end, what I really have is nothing more than 2 times the natural log of this ratio. I want a yes or no response. Is this a finite fixed real number?
Yes.
Yes. Therefore, by the integral test, since this improper integral converges, what can you say about my original series?
Converges as well.
It converges as well. Here's the downside. We are no longer in Kansas in the sense that I no longer am using something called the geometric series test or looking at a telescopic series. It's not that this particular value is what my series converges to. I'm just simply can proclaim via the integral test that my series converges. Did you guys see my point? I don't know what my series converges to. This test does not tell me that. It just tells me that I converge.
So that
You know what? With integral tests, I can get a range of actually how accurate I am if I choose just a few number terms. If I choose n terms, I'll talk about them in a minute. That's true.
so that finite number represents nothing. It just represents that it converges.
It doesn't actually
Good.
converge.
I think it just simply means that my particular infinite series converges, but not necessarily to that number. No. And by the way, with the remaining tests I give you, it's always going to be the case. I'm not going to give you tests that tell you what you converge to, just yes or no whether or not you converge.
So how do you find out what you converge to?
A lot of times I don't have the ability to do that. But a lot of times I don't care. Because to be honest with you, I'm not going to restrict my attention to just silly little independent series like these. I'm going to actually be looking at something so much more sophisticated. Just give me a couple days. I'll call them power series.
So what is the relevance of, say you're given a series in a real world application example? What
In a real world application, mostly, for what you and I are concerned with, you're not going to see a series just in terms of n's, but a series in terms of n's and x's, and we're going to talk about it as a function of x. You guys got to give me a couple more days. I want to take some baby steps first.
well, what is this a precursor to? Because a series and sequences just, I don't know.
I think that's what it's a precursor to. How the heck can you and I program a computer to compute the sine of 1.2 radians? And I think we can do that if we get a firm understanding of series. I'm not talking next semester or next year. I'm talking next week. So in the very near future, you and I will be able to tackle this issue, which I think is hugely fundamental. If you look at the computer technology we have right now, it's the year 2013, but it's so darn limited in the sense that computers only understand something basic like addition and multiplication. If that be the case, if I could construct some series that only involve the operations of addition and multiplication that represent the sine function, then maybe I can carry out that series to a certain number of terms to guarantee me whatever accuracy I desire for the evaluation sine of 1.2 radians. When you turn on your calculator or computer, it doesn't understand what the sine of 1.2 is. It's cheating and coming up with an approximation with basic arithmetic operations. I think that's one of the key issues why you and I need to compete with these students. Just one. So everybody, I will not accept this answer. This is not good enough for me. Because today I'm giving you quite a few techniques for computing. Excuse me. I'm going to give you quite a few techniques for determining whether the series converges or diverges. Here's what I want from you. Therefore, my series converges by the interval test. I need you to tell me what test you use, and I need to tell me what the conclusion is, whether you got convergence or divergence. I absolutely demand that. Now, you guys, I think I blew it. I'm serious. I blew it. I missed a lot of work. I think for me to be using the integral test, I should be taking the time and taking a peek at the corresponding function, whose output in terms of x is this, and see if it's even legal to use the integral test. Although I think in this example it's pretty straightforward. I need to test whether or not this function is strictly positive, at least for values of x on up. Oh, shoot. It involves exponentials. Clearly it's all positive. Number two, I need to determine if my function is continuous. Oh, but shoot, the denominator is never equal to 0 in this case, so clearly it's continuous everywhere, over the entire domain. Number three, I need to check to see if I'm decreasing. Cheapers. The output's a constant divided by something that's increasing without bound. Clearly it's decreasing, isn't it? So I think all three prerequisites are clearly met. If it's not clear, oh shoot, you got a lot of work to do. You got to verify those conditions are being met. Well, I'm running out of time. Do you guys think we can go to a more complex example instead of something simplistic? I think that looks more complex. But I'm losing my voice. So can we take our 10 minutes?